But on the train, yes.
Sushi?
Oh, I wish I could, but
It's too much contaminated fish. Thank you.
okay. So yeah, I will have a sushi tonight for the celebration. So this is my plan.
Did you go to TEPCO?
Yeah.
Did you go to TEPCO?
No, because as I mentioned, as I explained to you, today is not the right
Good
timing
day.
because it's the end of the business calendar.
Okay.
They have a kind of half day off, so
No
it's not
problem.
the right time.
No
But
problem.
please let me find out the solution. I mean, I'm going to make appointment properly, and
Go to
then
Tokyo. When you go to Tokyo, do it in Tokyo this week.
I think it's more
More
efficient
appropriate.
to.
Okay, no problem.
Okay, today we have I'm back to the first experimental place. It's lab, and then I come back to check the results. There's a result.
Increase or decrease?
Not many changes, but he will bring the paper. And then also I would like to tell you that now he has a water sample which has a high contamination, 400 becquerel. Are you interested in to work with CO2?
Just drop a bit of your CO2 in it. Yes, let's do it here independently twice.
Okay. Oh, thank you. So here is the result. ありがとうございます。Here
It's
is
good
the
to get the.
result.
Okay, what are the results? Any change?
Okay, so now これ時系列に並んでる。
回数書いてありま
回
す。
数が、そうでした。This okay.
Just let's have a look at the time and the balance. You want to see if it's a stable position or a variable position. Okay.
It was, yeah, when we finished the experiment in here last time, it was showing 130, and it showed 128.
But what is the bottom one? 90, 38, and can you bring the original data before starting the test? Is it with you?
Yeah.
Because we got to see it physically in all the matters. The first test, the raw material.
Was 414.
Yes, but we want to look at the cesium 137, cesium 134.
Please find out. Okay. This is the original.
Okay, put them next to each other, please. What's the last one today? Yesterday. What's his last reading? This is important. Look at the hour on your paper. You most probably got the time on it. This is the 24th at 1917. You should have something like the 30th or 29th.
129.
Okay, 29. Can you put them next to each other?
I could see the 127.
Okay, put them next. We see the okay. You see the cesium 129 it started from 414. The 131 is still nothing. 137 was 297. Now is what? 297 is 90. And 134 was 116, and now is 36. And K40 is 167, it's come to 36. So in fact the material is affected across the spectrum of the radioactive material in two levels, high and low. K40 is a low-level radiation, and cesium is one of the best we know. So the copper oxide has done its job. Okay, Yukoko, I think it's a very fantastic. That's perfect. Thank you very much. Can you put them singly in front of the screen, the first and the last one? That, yeah, we're gonna do a photo shot of this. Yeah, bring it right close to the screen because we don't see it full picture. Yeah, and the date. Go down a bit. Go up or down, down. Yeah, down, 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 down. Okay, that's good enough. Now the other one, please. The last one, which was the 29th. Okay, just that. Okay, that's perfect. Go down a bit, we see the date. Go down, 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 down. Okay, that's perfect. Okay, Yukoko, you you have a fantastic opportunity now with this guy offering you the water.
Yes.
Yes. Go through the same process for recording bases for the material, for the liquid, and use half of your CO2. Shake the CO2 very well after he gives you the measurement. Yeah, half of that should be enough, but depends how much quantity is there. Where is the water? Can we have a look at the water? The contaminated water is
measured in a small container, but this is the water. But the technician guy doesn't know what is exactly is, but actually this is used sample of previous experiment in Japanese university. So
where
that's
did it
why
come from? Where is it coming from?
This is from the laboratory of the Japanese university.
Yeah,
no,
yeah, but where did it come from?
これは土壌から汚染水作った汚染水。
So they actually they filtering the soil with some iron or some metals to extract the contamination from the soil, and they made this highly concentrated water.
Yeah, but ask him, does he carry any tritium in it? Can he measure tritium with his system?
Yeah. He doesn't have a measurement system in here for the tritium, unfortunately, Mr. Kesha.
Okay.
Hello?
No, what? Yeah, I'm listening. So what to do? Let him bring his sample, the one he's measured. Yeah. And we'll have a look at this quantity because I don't think you have enough CO2 to make such a effect. And I want part of that CO2 to...
It's going to be smaller than this?
Half of that should be okay. But he has to measure it. He has to measure it, give us a measurement for half, and then in that half you add what do you call it? Half of your CO2, and we see the confirmation and what if it goes the same way, or we get a limited radiation reduction.
Okay.
Yeah, because that CO2 you carry, I have to build a system for it to produce it. And please bring part of it back because I've got to give it to somewhere else.
I keep in the sample. Yeah.
Yeah, no, the CO2 material you're carrying.
Yeah, okay.
Use part of it today now, and keep part because when you go to TEPCO, you got to give them. They want to do the same test.
Okay.
Okay.
Yeah.
This is a part. This is a part you got to try. You're like the mom and with a lot of children, but they all are hungry. So you got to feed all of them a little bit.
We have to fight for this.
Yeah. Just shake it very well. I'll divide it in 2-3 parts. Even the contamination material try is very highly concentrated. Okay, no problem. But dilute dilute it slightly, that, or do we need to dilute it? I don't know. Just put a third in it and we see what the reduction shows and how it works. If it jellifies like last time or is not enough to do it. So maximum is I have to build your system in next 2-3 days.
Wow. Okay. So now in the sample is in the measurement with the smaller container.
Okay.
So
okay, let's see what it is. This is a gift from gods, as I call.
a gift from
is
you.
Actually,
Yeah.
a gift. If this guy has found the water and we can have a measurement and we can repeat it the same in an independent lab somewhere else, this is a gift. God loves you. So try to. You saw the effect on the measurement yesterday. So you need about the same amount of liquid. Okay.
Okay. Okay. Yes. So I will get my my cylinders and then measuring.
Don't get your syringes from yesterday because I think it's contaminated. See if he's got a syringe. I just pour it in, just shake it and just roughly put a third in. Try to use, show him the tub you're carrying, tell him this is the amount of water you want. You know the container you showed me the water in, which you brought from the other lab with you? No, the other one. The other ones you brought with you now. With drinking, yeah. Tell him this is about the same amount of water we want to use.
Okay, yeah.
Because then if it's a ratio dependent, then you're within the same ratio.
The smallest container they can use for their system is got a different shape, but これちっちゃい大きくなる。
Use the smallest container. See what he has.
One they have.
Yeah, use the smallest. Tell him, Yukoko.
Yeah. Yeah.
Tell him we noticed the last time you went in the room, in the back room, that he had a lot of samples of rice on the table he was measuring.
Yeah. Would you like to see?
Are these contaminated rice or is it non-contaminated? Ask him.
Because this is the company for the quality assurance of the local food production. So it's on the measurement. It's not contaminated, but some of them...
Does he have any contaminated food with him?
Okay, let me ask.
If he has, we want to test it with some CO2.
汚染もしその二酸化炭素で対処ができるかもしれないんですけど、汚染が見られる食べ物って
いや食べ物で汚染って
そうですよね。これだってもうそうですよね。Those are all not contaminated.
Does he have any contaminated? Any level of contamination?
どんなんでもいいんですけど、なんか少しでも今、違うお米じゃなくて、何か食べ物、食物でサンプルがありそうなの。ジュースとかないですね。
今はないね。
こっちはないですね。今はない。No, at this moment. 昔野菜なんかありました？今までその検出されてきた中で一番その例えば高い
のは椎茸。キノコ類。
Okay. They previously have the mushroom.
Do they have one here or can they get hold of some?
乾燥椎茸とかそういうの。Now it's gone, sorry.
Yeah, but can I ask you something, Yukoko?
Yeah.
Do you know the small syringe you have?
Yeah.
Take a small amount of like about 10 milliliter or whatever, or 5 milliliter from the syringe and leave it with him and tell him if he gets a radioactive material or radiated material, whatever, after he confirms that they are radioactive, just put some of this material in it and see if it gives any difference reading. If the material absorbs radiation from food. That's what we want to find out. Yep. And then if you can let us know if that happens. We lost her?
Yeah.
Okay, she's back. Hello? Yukoko?
Experiment.
We lost you. Can you repeat it again?
Okay, so I will speak with him. I'm going to leave a very little amount of CO2 in the little syringe.
Very tiny amount. But get the water in the top and measure it in the same level, please.
Water inside of the
no, the
measurement
contaminated water. Yeah, the smallest. Can we see the smallest container he has?
Yeah, this one. No, this one.
Okay, that's good enough. Put a contaminated water in there. Let him measure it. Give you the reading. Yeah, that's good enough. And then.
It's now. Yeah, it's in the process already.
That side.
I send it to the system. Yeah.
That's okay. Fantastic. That's perfect. I have a meeting at 10 o'clock. People coming here. I'm going to make a call. I'm going to make a call. This is important. Okay. Yukoko, you carry on with the experiment. I've got to go and make a call. I'll be back in 10 minutes. Okay. But everybody else is here. We are not switching off. Okay. Okay. Bye.
これに私物
そうです。水はもうやるっていうありがとうございます。父もちょっと今このデータ見てもし水ですか。
会社の数式なの うん、ちょっとそこの機械拝借してきちゃったので、ちょっと
Coco, where are you? Yeah. I can't see you. We can't see you. Can you see you on camera? Hello?
Oh, sorry, I was in the next room. So.
Yeah, can you show us when you're filling the containers with CO2? Is the reading finished?
I'm measuring now. So.
Have you haven't put CO2 in yet, have you?
CO2 solution or CO2 sample?
Yeah, the CO2 solution, yeah? When he takes it out, show me what it is, how much is the water in that container, which he has. And then I'll tell you what to do next.
Okay.
Okay? Yeah, thank you.
Okay, so you are running?
No, I had to go down and cancel a meeting at 10 o'clock.
Oh, so sorry.
This is important. This is more important than anything else. Marek,
We still on the measuring.
when you're making the dossier, especially about this place where
That's too dangerous. Has to be under of 90.
But you know, in the small reactor you showed me yesterday, the first one, you have, is there any way we can seal it without screws? Because then you have metal in the reactor down. Is there uses that we can use it without using the screws compressors? Then you have some to nanocoated plastic. No, the screws. Which are trying to do. If you give me the box, and go with the guys,
I look the composition. Yeah.
Position.
Even the alum
Never
that
send
you
it.
are
Never send the No, exactly.
That's my way. The only way I go is there.
Yesterday was gorgeous. It was good.
Wouldn't
Oh,
have-
you have
it-
to see Italians.
Unbelievable. I will never take a car again. I was stuck in the traffic like I said, what the hell?
I told you.
Now I found all the entries
Backwards.
and backwards. I know it exactly.
Yeah, but the thing is, the tourists who come here a long time, they know those as well. The easiest way is to park the car here and walk through the fields across the.
I realize that.
So, this do you find a lot of problems here?
So we can't use it.
Do not use it as a deodorant to kill your
That's
smell.
it.
Just use it for yourself. What do you do with it?
When you shave, you put lenses to detect the burn of the shave, or you can use it as a deodorant.
That will last about 100 years with us. We don't cut ourselves anymore.
Yeah.
So it's aluminum salt.
Aluminium.
It's
Alum. Here.
alum, which is in fact potassium aluminate.
What's the concentration of that one? Potassium? Oh, that's a lot.
Yes, because it's aluminum, potassium sulfate.
Yeah,
Epsom salt.
what they kills all the.
It's called Epsom salt.
Cut yourself and see if you get it. Let me know it's the correct. What does it say? The percentage, the content of sodium?
Well, the content of no potassium.
Sorry, potassium. What's the content?
Well, it's one. Just have to see the weight. Potassium is 40, just about 40. To be around there, just 39, 40. So aluminum is obviously
It says gold, chicken egg. He can't see, so he's got to believe whatever we tell him. It says. He can't read.
Oh my
He
god.
hasn't got his glasses today. It says this type of salt usually contains metal impurities and certain chloride, being candidates iron, sodium, chicken egg, chicken wing, McDonald's, cesium. No, it's nice. Where have you lost your glasses?
I don't know. I have it. I told you. I brought you one. It's broken.
Yeah, but it is because of its high, because of its heavy content, because of its K aluminum sometimes for oxygen, it can create beneficial for the heavy material, which is this.
So can we use it?
Mm, potassium creates a green color. If you have potassium in your blood, your blood color will be green. So most probably in the other container you're producing blood. In your container you'll see a green Martian. But you gotta powder it.
You need a spray because to active the May alone 3 days. And how will you combine Come on, man.
Did
I
you-
sent you one package, I cannot get it now. You want me to send another? I have to.
Yeah, hold on.
Oh.
Yes, yes. We can't hear you.
Let me move to there is my battery is running, so.
Okay, okay, charge yourself up.
Okay. So I'm still waiting for the water sample, but it's got the 600 becquerel more or less.
Yeah.
So the
It's a
container
highly
is coming.
contaminated water.
It's very high, yeah, very concentrated, very contaminated. And also here is a sample of the dry soil.
Ooh.
Are you interested to work with? No.
Okay.
This has this.
Let me see.
amount.
Can you bring it forward, please?
45,675.
That's the soil.
Yeah. That's the soil, dried soil.
Right. So, okay.
Rice field.
Okay. Let's have a look at it. Let's have a look at it. Can we look at the container?
Yeah.
Is that all the dust is going to give you?
No, he has another packet.
No.
of
I don't
this.
want any more. I don't want any more. That's a bit
Okay.
too much. Can we have half of that?
Okay, but we need to measure it again.
Yeah, let me
To
see.
check.
Can we have a look? Open the top of the cap, please, if you can. You don't have enough CO2 with you. That's a problem.
Yeah, that's true. このね、液体のね、量が足りないっていうのが
Let's
問題なんで、ちょっと
Don't breathe on it.
So-
Just let us have a look. Can you turn it into the camera, please? Just turn it into a camera. No, okay. We need. You don't have enough CO2. You need half of this. And we do experiment. I prefer. Let's do the water first, and then we consider this.
Okay.
Because the water you have already tested on the water with a lower contamination of 400.
Yeah.
If we can,
Yeah. Okay. So I'll take the water sample.
let's, how we can get that. Who wants to fly to Japan? You have no passport, so you're an alien in New York. You are the same. You're a Belgium alien in New York.
I have mine.
I don't trust to send you to. You won't come back from Tokyo. Americans don't need visa for Japan, do they? No.
But he has his passport.
Well, he's got his American passport with him, so American can go no problem. It's worse. We never get him back.
It depends what flight has to be taken because
Yeah, but it's not only flight. I have to build a system. It's another 3 o'clock night again tonight and tomorrow night. I'm getting Yukoko to cancel her ticket. To delay it if he can go back. Let's see what it is. We'll see. We can always send it by DHL to them. It's better to finish a test or 2 half chickens, huh? Let's see, we try to keep a little bit behind for TEPCO because I kept some here. I have material here for our test here because I want to send some to Tehran today or this week to be tested. That's huge. How much was yesterday? One was 85, the soil.
soil
Was 85,000 or 82,000? This one is 45,000.
Yes, about half.
Read from here. Use your eyes. You best see you're younger than me.
The first
Yeah, 45.97.
46 4 6 0 6 7 6.
It's 45,000. Yeah, but it's not as contaminated as the one yesterday one. You're back? Okay, this is the reading of the water we're going to test, yeah? Hello,
So
you
here is
Coco.
the water sample. Hello.
Hello, what is it?
Hello.
641
Hmm?
is more contaminated than the other one. Does he know where this water comes from, you Coco?
This is from the farmland. I mean, 土壌から出たんですよね。土壌に水をこう入れて、かき混ぜて、例の鉄を使って、This is from the farmland, and they mix with the water and then extract it.
The way we did last time here.
Hmm?
The same as what we did
Yeah.
last time and yesterday.
Yeah, it's the same area, same area.
Yeah, same. Okay, can you... Is the water ready now? We can see that we can test it?
Yeah. Sorry, could you repeat it again?
Is the water ready that we can test it?
Yes, here is the water. Now he's
Yeah.
measuring the weight. Okay, so it's ready. So it's a 57 gram.
Okay.
No.
40
40 gram. Exactly.
40 gram. How much was the... Is that the material which is measured?
This one?
No.
It's also...
That's the reading you showed us is to do with this water. That's the water.
That's the water. Yes,
Okay.
this is this one.
Okay, now go back to your CO2. Shake it well. Shake it very well. Shake it very well. Better. Upside down. Upside down. Upside down. Shake it very well. Yeah. Now take about 20 mil of it or 10 mil of it. Let's see. Yeah, take
Do I
10
use
mil.
this?
Yeah, take 20 mil.
20 milliliter.
20も使ってするんだけど
Don't let it settle because you need the bottom. I know. Shake
Yeah,
it
but,
very quick.
it's-
Yeah, very quick. Take as much as you can very quick.
So it's a 5 milliliters.
Yes. Two. Go to number 2.
20
Good number?
2.
2
Yeah.
milliliter.
2 milliliters.
2 milliliters.
2.
Okay.
2.
Ah.
Hey, you're losing on the floor. That's a gold dust.
入んない
It's okay. Listen, Just tip it up in the liquid. Tip it in the liquid. Tip it in the liquid. No, in the liquid direct. In the liquid direct. Shake it.
Yeah.
Put your finger on it. Tight it very nicely. Yeah, okay. Now shake it. And put a little bit in the liquid now. Put it in the
I have a
water.
long cylinder. This.
Okay.
This-
No.
She has the way she can.
You got the scale. Go to 65.
No, it's 40.
It's 57 now.
Do-
Oh yes, 57.
65。
Yeah.
65?
It now has a no. Now has a 57.
Okay, go to 65.
65.
Go to 65, yeah.
So 15 grams.
Yeah, just put in, we tell you to stop. That's irrelevant. Just put in. Open the container and stop dropping it in. Just pour it in.
There is a weight for the container also. So now it
That
shows
doesn't
the
matter.
57.
We do that later on.
2 milliliters.
The thing is to get the material in.
Mark it down those values.
Doesn't matter. They have it. Okay.
You should go to 59.
Okay, go quick. Don't wait. Just go. Just go. Go inside. Go directly in the water. Don't put it somewhere else. No.
No.
Okay,
Just
he's
the scale,
measuring.
yeah.
Okay, now he zeroed it. Okay,
Now
go.
it's a 40 now, so it's.
Okay, go, you coco.
I'm adding.
Very slow. Yeah, go faster. Go faster. You're dripping everything out. Put the cap on the side. Put the. Go. Okay, that's enough. You lost most of it. Doesn't matter. It's okay. Just pick it up with a syringe and put it in. It's okay. You got plenty of it. It's okay. Don't worry.
Now we have 45, so it's 5 grams. In it.
Okay, the liquid which is on the scale, try to get that in there as well. Yes, thank you, doctor.
私がこぼしちゃったやつ。そうです、
Yeah.
もったいないね。
Thank you, doctor. Very quick. Yeah.
Really sorry for my big foot of a golden dust.
Yeah, stop.
It's okay. Doesn't matter. That's enough. Just shake it and leave it. Close the cap.
And do a cocktail.
No, it's not done. It's half done. Open it up. It's not tight. It's not done properly.
今ね、
よく見えますね。私
No. Yeah.
Okay, now, yeah.
Tighten it. Shake it.
Mhm.
Shake it a bit. Okay, let it sit. See if you see the jelly form as yesterday. What's the weight now?
It's the 53 including the bit, but it was 45. It shows 45. So we added the 5 gram of this.
Okay, wash your hand, clean the table, and throw that gloves away. Don't touch those gloves again.
Oh,
I put the new gloves.
Open it and have a look. Clean the scale. There is a underneath the cup. There is some. Clean the cup underneath of it. Underneath, yeah. Okay. Yukoko, have a look and see if you see that jelly formation as yesterday. Doesn't look like it, does it? Open it. Open the cap, please. Do you see that jelly formation as yesterday?
Yeah.
Yes or no?
Use that something to yes, yes, I can see some. なんかこうちょっとドロッとした。
Just see the texture. If you have something very small that we can see the texture.
Okay.
Can you put camera closer?
Yukoko. She's not there. They're going to get this spoon.
We have a stick to show you that inside. So,
Yeah. Just can we
Yeah.
have a look inside with the camera first? Can we look inside the liquid? You can't see much. It looks like. This is milk. Okay. Just can you put it down and show us how it looks texture-wise? What do you have to poke in? Does it feel like jelly?
let me.
No.
Yeah. No, don't
Can you put something on it? Because yesterday you had like a residual mess.
So I use the chopstick.
Yeah, chopstick. Yeah, no problem. In Japan, you have to choose chopstick.
That's true. Okay, here is like.
Do you
It's-
see like a solid bit like yesterday?
Yeah.
Yeah?
Like, yeah.
Do you
Can
have
you see?
anything at the bottom? Anything sitting at the bottom like yesterday? No. I think yesterday, because there was some wheat residue, they stuck to it. That's what it was.
This is the
You
sink.
see this
Can you
one?
see?
Pardon?
You see some
This is the
the
sink.
jelly?
Ah, it's a gel there, yeah. Okay. I think you can test it now, Yukoko.
Yeah.
Yeah, but throw that wood in the bin. Don't touch. And you need to wash the table. I see a lot of residual on the table of material. Just let him to test it now. That should be enough. Should give us a good indication. So it solidifies. It jellifies. It doesn't solidify.
でも
今ちょっと浮かせて、そろそろこう見る。どういう状態か。
Okay. We're seeing the table. Can we see something else?
So I
This is a live broadcast from Japan, Fukushima. Would you like to make a comment as a knowledge seeker? Make a comment.
I only joking.
Don't joke. They can leave it live. When you say anything, they're right to you. Why did you say that? You can say it in Spanish.
Estamos viendo la mesa. De momento, solamente. Este es uno de los análisis más importantes que se han hecho para demostrar la eficacia de la tecnología que se en muestras radiactivas.
I think with this experiment, she's got enough to see the dust. So we'll see if you can do it with the dust, just not with liquid. Oh, it's enough of that.
Lo que estamos viendo es CO2 en estado GANS.
We don't want to dilute it with water.
Es capaz de absorber la radiación.
We have a chance to do it with a dry, because last time we washed it, in there they gave us a mud. It was already moist. We got to see if it does with a what do you call it, with a dry. Then the farmers can pick it up directly on the farm. But it depends what the test comes. Okay. You have seen 2 days of experiment. This is a blind shot.
verdict is reducing, complete reducing reduction.
No. How much?
Well, I bet for complete
Odd
because
and
of
evens. Odd and evens. It's blackjack.
it should be completely reduced and disappear, not measurable.
You have a coffee if you win.
I never drink coffee.
That's why I offer you. It doesn't cost.
I think it will be.
This is introduce yourself.
I'm Marek, knowledge seeker, and I think the result will be zero radiation
In the water.
In both water and residue.
Water
If you want to speak in Czech to your people, then you can put it up. You can explain.
Zdravím lidi mluvící česky a rozumějící česky. Vysíláme z Fukushimy, kde provádíme testy dekontaminace radioaktivního materiálu, v tomto případě vody. Používáme GANS materiál CO2, oxid uhličitý v kapalném GANS stavu, který přidáváme do radioaktivní vody a mohli jsme vidět proměnu vody do gelovitého stavu, kdy došlo ke srážení, k magnetickému přitahování, ke srážení radioaktivního materiálu. A nyní probíhá test a výsledek uvidíme za chvíli.
L'expérience qui est produite maintenant, donc je me présente John Skelton de Belgique. Je décris ici un petit peu ce qui se passe. Nous avons une eau contaminée fortement et dans laquelle on a mis du CO2 à l'état GANS, c'est-à-dire cet état nano du CO2, et le résultat doit apparaître bientôt et normalement ce CO2 à l'état GANS doit supprimer la radioactivité dans le matériau testé, c'est-à-dire l'eau qui a été donc à laquelle a été ajouté ce CO2 à l'état GANS. Donc on attend maintenant les résultats de l'analyse. Donc le niveau de radioactivité initiale était de 440 et le résultat, bien, nous l'attendons, mais il est fort possible que le résultat soit zéro, non mesurable. Donc on attend ça. Donc ça c'est simplement les conditions, l'état de ce matériau utilisé qui permet une réduction. Donc il y aura certainement réduction, maintenant voir jusqu'à quel niveau, on attend les résultats.
There is somebody moving there. I can see a shadow. Hello, Yukoko. You're still here.
Hello.
Oh, you're there.
Now we have a clean table.
Oh, we have a clean table. Good. We just see your hands. You're like a magician, you know. You see two white hands. That's just you too.
Yeah.
Have you seen any indication of results?
No. Because it's small container, it takes 30 minutes.
That's why it takes a long time.
That's right, yeah.
Okay, now while you were away, you can turn your camera up a little bit. We can see your beautiful face. Higher, higher, higher. Okay. Everyone here has spoken in their national language. If you want to speak in Japanese, what you're doing, because it's recorded. Or if you can explain in half an hour what you've done yesterday and when you are, because this is more important to the Japanese community than anywhere else. So feel free and speak as you like.
Okay, thank you, Mr. では日本の皆様にケシュ財団の、実験のご報告をさせていただきます。2日間にわたって福島県内、3日間ですね、3月28日から31日まで、実験を2団体のご協力をいただいて行っております。ナノ物質、福島のビデオで、作成方法をご覧いただいた物質、それからですね、ガンズと呼ばれるこちらも、YouTube で、作成方法を公開しております。ガンズの、二酸化炭素 CO2、それからガンズの、コッパーハイドロキサイド、酸化銅を利用した実験を行っています。昨日の段階では、大変30ベクレル弱の、検体ではありますが、完全にこのガンズによって、放射性物質を
Can you push your camera up? We don't see your face. Just a little
Okay.
bit, okay? Sorry, thank you. Carry on.
ケシュ博士の期待値としましては、物質によって、また再び汚染水が飲むことが可能なレベルまで、除染できる、ドリンキングウォーターのレベルまで除染ができるということを期待しております。本日は、また同じ実験を別の団体様のご協力でさせていただいておりまして、今回の検体は641ベクレルトータルで示している大変高い、汚染水を利用しています。後ほどまた結果をご報告します。Okay, thank you. I think
Thank you
I'm
very
done.
much. Do you want to explain what you did yesterday and what the results were yesterday?
For the Japanese audience?
Yes.
Mr. Kesha, I am discussing with the Japanese supporter. We will have a workshop to announce all the results especially for the Japanese audience. We're going to have a meeting today, this evening. So hopefully we can do it while I'm staying here, in Japan.
We're going to announce this within the next 24-48 hours.
Yes.
So you have to be in line with us that you don't fall behind when you're in Japan if you want to do it. Yeah? So I'll leave it with you.
Okay, thank you.
No problem. Thank you very much.
I set the date for the workshop, so I will.
Yeah, if you want us to be with you while you're doing the workshop, we'll be there.
Yeah, we need you to.
Okay, no problem. Let's see what this result is.
Okay.
Okay, we wait.
Yeah.
Thank you. 941 or is it 641? 641. This is a highly contaminated material. And the contamination, if you look, is continuous. So you see the level here, and it goes here. If you look at all the graphs she showed us, they all show the cesium, potassium. Because their machine is geared up only to measure these two. The problem with these systems
Mr. Kesha?
Yes, you come on. Yes? Can you talk
Situation.
louder? We can't hear you.
Yeah, this is the situation. This is just in halfway, still in halfway, half done. So it's
Yeah.
been 15 minutes since we start measuring,
Yeah.
and I could see the results that it doesn't have that much change.
Hmm.
But is there any? Of course, we have to wait another 15 minutes for the results coming. But is any? Would you have anything? Any idea that what is happening now?
No. You gotta do the same thing as last time.
Yeah.
That you have to separate the water from the residual,
Mhm.
and then we measure the water separately.
Okay.
This is the process. Yeah. You gotta measure, separate the gel. That's what do you call it? That's the process. And then we see what stays where.
Mhm.
And then if need be, we do a second test. You have enough material there.
Mhm.
Yeah, but we are looking for the water contamination, what residual left. Yeah?
Yeah.
Okay, let's see what the results come. Do you remember the last time the CO2 before separation was, what was the reading of it? Because it showed radiation when it was on its own. When they were together and we separated it, CO2 gave a different result, but before they separated it showed the radiation. You Coco? Hello? You Coco? The results yesterday when they gave us the CO2 before we separated the water, can we got that figure with you? How much it was?
It actually shows an immediate change.
Don't
It
worry,
is
don't
so-
worry, you got time. Because what we're gonna do, this is a very good result, depends what comes with it. We're gonna, if the ratio is about the same, you got him. Oh, finished. What was, can we look at the CO2 before separation? After you added the material to it, please.
You mean yesterday, from the yesterday?
Yeah, from the other lab, yeah. This could be a critical mass positioning. As we just talked yesterday, we need certain amount of CO2 to achieve a target. So what we're gonna do, let's see what's the measurement. If it's about she's got the papers with her there now. Not detected. No, let's see what she gives us. Let's what comes out. If you're on 134, no detection, then we will carry on with something else. It means we need to add more material into the yeah. Let's see. Okay, let's see what comes out. 52%, which is half more or less in the first result. We got the papers, Coco, it's okay. So we have to add further CO2. This was 45 to 72, which is what, 15% we added by mass. Yeah. 7 gram to 40 gram. It's about 20%. 45 to 52 or something, 57. Coco?
Yes.
How much was the weight of the material you just put in?
The weight was originally 40 gram, and we added 5 grams. So now it's 45. And actually, Mr. Kobayashi already calculated.
Yesterday was 95 to 112 or something, 120 something gram. It's the same bottle. Yeah, because we shake it, you assume to be the same bottle. So yesterday we went up by 20% to see the reduction. So at the moment we are at about 12-15%. Yes, Coco.
Yep.
Hello.
Hello.
Yeah, what's the result?
Yes.
What's happening?
So the
Can you
result is
turn the
coming.
microphone up? We can't hear you. We cannot hear you. Turn the camera up that we can hear.
No. The result is coming. So, but it seems like there is not many change in
Okay.
this measurement, but we can see that the sediment and then going to the next step.
Okay, what we want to do is we gonna add some more CO2 to the system.
Okay.
Yes. You need some more. This time empty it in a container that you don't lose so much, and put it by syringe. Yeah.
Yeah.
Empty it in a container and use it by syringe. How much is the weight now? We put 5 gram. Yeah.
We put the 5 grams. So now we have our. Okay, I bring the scale.
Yeah. If we add another 5 gram, and then we still have room to do another 5 gram to see if it's radiation is mass dependent.
It also may depend on time.
It's got to be instantaneous. It's usually instantaneous. Yukoko, somehow here we don't hear her properly.
We have a scale here, so we can.
No, you're not going to use all of it.
Oh, no. We're not going to use all of it. Yes, but use this.
Okay, empty it in there. Empty everything in there.
Now it's still in the measurement. So should we wait for the sample?
No. Empty everything in there. We want to learn something while you're there. This is for us, not for them.
Okay.
Empty everything in there.
これ綺麗なあれですか、ね。
綺麗。これで測るの？
いや、測るんじゃなくて、今またちょっとこの中身を見たいっていうことなんで、もうこれで今回私がこぼさないようにここに全部開ける。
Everything in there.
Yeah.
So you can put a little bit of water in it and wash it out. Yukoko?
Yeah.
Just a little bit. Just put a few drops of water, plain water.
Okay. Tap water. No,
Yeah, plain water. Just a few drops.
Okay, I did.
There's no residue at the bottom.
Yeah.
Okay, no problem. No problem. Leave it. You don't have to beg it. It'll come out whatever is there.
Yes.
So let's see what the results is.
Okay. have a result.
Okay, what's the result? Can you speak louder? We can't hear you.
Okay. I can see that the big sediment. Now we have a clear water back.
Pardon?
This is the sample. Now I can see that there is a sediment and it start to separate it to the clear water and the sediment.
Okay.
Can you see? And
Yes,
so
we're
then
going to separate it now. They're going to give us... can we have a look at the pictures?
Pictures of the sample?
Yeah, we want to see the sediment. Just bring it up, please. Let's have a look. Don't open it. You see there's a piece in there now. See it? The bits of it, okay. Okay, can we have a look? Have the results?
Result, yeah. Sorry. Here's the result.
Can we see the original? Can we see the original result? The result, what the actual figure of the water? Okay, let's see. Before testing. Can we see it up? 600 and... Can you bring it forward? We can't see both. 641, 532, 476, 165. No. There is something I wanted to see and I've got it what I wanted. Okay. Yukoko.
Yep.
Just bring it back. Just keep it there. Don't move it. Is that 641?
641 becquerel.
And your 134 has increased from...
134 is increased.
Yes, that's what I wanted to see. Yeah. Okay. Now, this confirms a lot of things. Can you open the container? Yeah. And add another 10 milliliter into this container.
Okay.
This confirms huge confirmation of what it is. The process converts. No, the process is converts by detection, but it's not enough to do something else. I'll explain to you in a minute. Let's do this.
Can you also find samples of the sand with the rolls?
Yeah, we can't carry it. She can't carry this radioactive material. She can't come. We cannot come out of Japan.
Yes, but it's more regulated.
Yeah, we do that later on. There is a very fundamental nuclear principle here. We just got to carry on testing.
Can you see?
Okay, add another 10 milliliter of this to it.
milliliter.
Yeah.
Can I use the big?
No. Use that one. Just do that. Just do.
5 milliliters.
Okay, do 5 first.
Mm-hmm.
Do 5 in one go, and then we do another 5 afterwards. Do 5. Okay. Zero it and add 5 milliliter to it.
Should I shake?
Yes,
CO2?
please. Yes, please. It's okay. Just shake it. It'll be okay. Take from the bottom. No problem. Very quick before. Go.
So I take 5.
Go a bit more. That's enough. Let's see. Just put 5 gram into it. That's enough. Let's see what it gives you. 4. Yeah.
4. Yeah.
Okay. Put 4 in.
4入れました。
Finished?
Yeah.
How much is added?
4
Okay,
grams.
I add one more, make it 5.
ここにします。
Okay, okay, that's enough. Now shake it, close it and shake it very well.
そして混ぜてください。
Shake it at it's leaking. It's leaking. It's okay. Okay, that's enough. Let's see. Stop, stop, stop. Yeah, I know. Can you clean that table? That's contaminated material on the table. It's not safe. And the container. Just leave it for a few minutes. Let's see if the jellification changes. And then this, I was waiting for this yesterday. I didn't see it, but now it's there. This confirms in so many ways that the slowdown is a step down to lower and lower. Yesterday they didn't give us the potassium. You Coco, can I have a look at your data please again?
Excuse me, Mr. Kesha.
Yeah, the 2 pages you had on your hand. Can we have a look at both of them please again? Let's have a look. We need your camera. It's too far. Okay. Can you bring it a little bit forward? It's too far to read. Yes. Can you bring the last paper right in front, please? The one on the left-hand side of you. Can you bring it close? Yes. And now the other one? The other page, please. Yes. This is a step-down process. Can you go back to the first one? It's a step-down process. The potassium has gone up. The lower radiations have gone up.
Yes, but this is not measurable actually.
Yeah, but that's what we
deviation
have.
is
The variation is small. This deviation is 495. It's bigger than itself, the figure, because it's in transition. Because this. Go back to the first one again, please.
Deviation is bigger than the results.
It's the same with the original one.
I mean, it's
Yeah, it's
not
400.
measurable.
So that. No. It's Mark is correct. It's not. Okay. This shows something which you are looking for. This confirms a very nice point. Can we have a look at the tube? How is the tube looking, please? The material, has it jellified? We can't see it. Can you open it and let's have a look? Does it look more gelish than before?
Yeah, I can see there's some white concentrated. Like,
Where is
can
your
I use
chopstick?
the- Yeah.
Is something physically you can feel?
Yeah, here is something on the surface.
Yeah.
Yeah, like
On the
little.
bottom?
Yeah. Bottom is more like, yeah, it's melty now. Can you see the
Yeah.
frost of the, yeah. So now it start to have textures, but still it's not that jelly as yesterday.
Okay, yeah, but we're gonna add more the next time. Can we have a measurement on this, please? Can you get it measured, please?
Yes. Okay.
Okay.
So now we have 50 grams.
Okay, no problem. You got some drops on the table. Can you clean that, please? This is a very, very, very. We're going to ask him to explain the graph. Let's see what they have been setting. You see 37 is coming down. You Coco, do you see anything? Hello? We can hear you. You sound like on the moon.
Hello, Mr. Kesha.
Yeah.
It seems we can see the change in the next measurement. It's reducing.
But how much?
300 something more or less, so it's almost half.
Almost half. Okay. What we're going to do...
Okay. Please wait for the final confirmation.
Okay, tell you what we're going to do. Doesn't matter. What you're going to do is you add another 5 ml to the next process, and then we separate the water from the gel. Okay?
Okay.
Okay,
So
this is a process. This test and the next one is for our education.
Okay.
Yeah?
Okay. Yeah.
Let me see the figures first. Let's see the figures. Marek, the water sample changed last time, yesterday, was 414. It came down to... No. When the sediment was in, there was a radiation. That's what I want to know, the radiation. So, the absorb... Yeah. What is the result? Yukoko, can you hear us? Hello? This looks like, what do you call it? The moon landing. The picture is always the same, 20 minutes before you see the next picture. Yukoko, can you hear us? No, she's in the room. The most probably there she is. She's running. I told you she's running. She's running. Okay, what's the result, Yukoko? Can you talk?
Okay, the result is 372
Yeah.
in total cesium now.
Can we see the original paper again?
Yeah,
Yes. It's a
original
process.
is 40 gram, which is this.
Okay, how much is the thingy? Yeah, okay, we can't see, it's too far out. Can you bring it closer? You went from 640 to 370, 268 to 475 and 102 to 165. No, it does that. The machine does it automatically background. Huh? Yeah, but it does. The machine does it automatically. Yeah, it does. It puts weight in. They put the weight in. Okay. No. Yeah, but that's beta factor. What is interesting, the cesium-13 has become more than it was originally. Okay, Yukoko, can you do another 5 milliliter into the container?
Okay.
Yes, please. And then you measure, and then we change the sediment. We separate the water and we do a test.
I will take the container.
This is crazy, but I tell you what's this craziness about it. I was looking. There is the new graph here. Heavy material. Hello?
Hello?
Oh yeah, it's
Here
okay. We thought it was a silent movie. Carry on.
No. Okay, so here is the sample.
Yeah, can
Now
you add
you
another?
can see white, some materials flowing inside of the water. Yeah.
Is there a black thing floating in there?
Black things.
It's a black material, no? Dark
I
material?
open the lid and
Open the lid, let's have a look. Or is it the magnetic field flows? Okay, let's see. Can we have a look? Okay. No, there is nothing there. Okay, just add another 5 mil because this is very, very important. You are showing your data, very interesting. What? Speak loud. We are not ashamed of listening. Explain.
If you increase mass, you reduce the average measurement.
Yeah, but the thing is yeah, but we are looking for energy, not mass as such.
should I mix?
Mix it very well. Yeah, I understand what you're talking about. You're correct, but we're looking in a different direction. Okay, just take 5 mil. Yes, a different. That's enough. That's enough. That's enough. That's okay. That's enough. Just add it to it. The white residual you see is what you're injecting into the material itself. Okay, let's see. Close it and we wait. Yukoko? Yukoko?
Yes.
Yeah, what I want to do is, okay, leave it for a few minutes. Let it just, you gotta shake it inside with your chopstick or whatever. Yep. Very nice soup. He pulled the shutter down. It's too late there. Okay, close. You can hear this shutter down. Close it. What I want to do, Yukoko, is that you measure this one, and then next time when you open it, I want you to, like yesterday, separate the water from the residual. And we measure the water to see if the water and the sediments carry any radioactive material. Okay?
Okay, so now it goes to the measurement.
Yeah, measure this, should be enough time to measure it. And then strange is that we are seeing increase more than before in 137, which just confirms there's a plutonium-uranium activities within the water. Because we haven't created any more, we got more 137 than we started. The only way is that it's reducing plutonium-uranium down the scale. They are absorbing, they are going through a decay reduction. In the graph you see on the heavier end material is suddenly expanded to plutonium. Yukoko, let them do, we ask Yukoko to explain to us if you are correct. Excuse me, in this office, on this side is free. Sunbed costs more. We make those luxury seats. We gotta take a vote. Are we getting rid of our resident spider, or we're gonna keep him? Sitting there, looking at us. Next food. Yukoko? Hello?
Hello?
Yes. Can you
Hello?
ask the gentleman to come? I want to ask him a question, please.
Okay.
If he's got time.
Open the screen, Yukako.
Let's open the screen, is open.
With
Make better pictures.
そうですか。はいじゃあここから。Okay. Yes.
Can you
Mr.
ask him?
Kobayashi,
Can we have the graph, please? The
can we have
first,
the graph?
the first. Yeah, we don't want the data. We want the graph. The first paper of the before we started the test. Okay. Can you ask him to explain to us the graph, please? Where is green and the 4 or 5 spots of green to the right? Can he explain this to us? His graph. Well, what is it? What it is? Yeah. Yeah.
あと見えない。
Let him explain.
あ、これが何かをご説明いただけますか？
これがって、
見えない。This part.
Go a bit lower. We don't see it. Can you put your camera down a bit, please? Yeah. Okay. Can you explain the graph to us, please? Yeah,
This part.
Yeah, and the big greens on the left.
このラインがカリウム40。
This is the potassium 40.
Yes. Yeah. And on the left-hand side, the big greens.
一番大きいこれが。
セシウム137。
This is the cesium 137.
Yes. Can you go more to the left?
This
To
way?
the beginning? Yeah. Go more. We don't see the picture. Can you bring the paper in the middle? Can you explain to us what's on the left-hand side?
This side.
Yeah.
これは
What is there?
これが見えない。
PB。
これライン2つあるんだけど。
はい。There is a two lines.
Yeah.
こっちが鉛。
This is the zinc.
Uh-huh.
要素。
This is the iodine.
What about further up to the end of the scale from 0, where the thing is? Go to the left. No, the other way. That's right to me. Left, yeah. What are these here?
このラインは何でしょうか？
これはね、自然界にあるものだから、
はい、
これ全くわかんないですね。
Those are the something is a natural radioactive, so I don't know what exactly
Do you
is.
see a plutonium or uranium line on the left-hand side? Does it start at that energy level?
これはガンマ線しか測れない。
This detector can only measuring the gamma. Gamma
From what material?
じゃあ主な物質としては
要素、
iodine,
セシウム、
cesium. I can see 134, 137, 134, but it's a different energy level.
Yeah.
カリウム40。
Potassium 40.
一応コバルトとかもラインはあるんだけど、測ってない。
This detector also can measure the cobalt.
Yeah, where is the cobalt?
Cobalt is here.
Bismuth
and the cobalt, but they don't read it. Those two lines. So, but there is a function in the detector, but usually it doesn't appear to the final.
No problem. 137, 134, energy different energy. 137. Okay, that's perfect. Thank you very much.
Thank you.
Thank you. Can I have your timetable, the table, please, periodic table?
この辺は137の強さによってこの辺はもうかなりブレンドです。
Yukoko, what's the halfway result? Planet Moon, Yukoko.
Yes, we are going to 300 something right now.
Pardon?
300 something, 330 something right now, but it's still ongoing. Sorry, Mr. Keshav.
Don't worry,
it's coming.
but what was the one before this 300?
Ah, okay. Now I'll show you.
The last result, the last result.
It's a 50 grams. This one.
$350, okay. Let's have a look at the result when it comes. Then if you can extract the water, separate the water from the CO2.
I prepare the containers.
Yeah, separate. You bring your doctor's syringe in.
Can I move back this
Yes. We're not going to use this. You need for TEPCO. This you look after this like your baby. You can't go anywhere. At the end of the day, if we can extract water which is clear, that's the purpose. But now it's a process. We can actually extract every nuclear material now. I can see the process. They can do that no cost. The only problem is the price of seaweed will go very high. There will be a shortage of seaweed in Japan for a while. I can see. Seaweeds. It costs what, 500 euro? 1,000 euro? Let's say 500,000 is what they're spending millions a day. It will rain. They just put a machine in the system. When it's done its job, they pick it up, they put it in another system. It just rains in CO2. No, with a solid. We haven't run a dynamic. If you run a dynamic system, it's totally different game. At the moment, it's a matter of showing if it can be done. Because this is to you or to normal figure, it looks like a static, but in reality, is a magnetic field between layers. It's still dynamic. Yeah. The problem is with this, the reactor is inside the layers, and the other one we create a reactor and we work it from outside. Let's see what the water contamination comes and what the sediment content. When we separated it yesterday, it was totally different when they were together. So we're going to see.
Okay, here's the results.
Okay. Can we see the first page again, the first material? Before we started. Closer, closer, we are blind people. 350, 340. 476 is the first time we see the process. Huh? This is the first time we see reduction.
There's a big change
Yeah, but that's the material. It shows the process as a material live active. But this one is 68 from 164, 47 to that. Okay, 64. Okay, Yukoko, can you separate the water from the material and measure the water, please? Gloves, gloves!
Yeah, I'll do. 2 drops each.
Wash the cup that there is nothing in it, please.
Should I use the purified water?
No, we don't want
rinse?
any purified water yet. Just let's do something at a time. One thing. He's got 2 machines or 1 machine?
Only 1 machine.
1 machine.
No, he probably can set up.
If
No,
he can,
sorry. He's in the office now, so when he coming back.
yeah, because then he can run the boat on the water and the reservoir. Okay. Try, I don't know how you can separate the two, please. Separate the water. Make sure the container you put the water in is well washed. There is nothing in it. Never been used or anything else because it could be contaminated. This water is the most important part. We want to see if we made any difference like on Monday. But I think there's a possibility air exposure does something to this thing. She's going very slow, very slow. Okay. Yeah, perfect. Be careful. Don't shake it, don't shake it. Open it very slow because I can see the water is separated.
Yes, but this time I can see something still flowing.
Yeah.
Not in the bottom. So.
Okay, very slow, very slow. We do the same process as yesterday, 3 bottles, yeah? We do the 3 bottle process.
Let me take the photo of this. Can you see?
Very slowly, doctor, please. Okay, we do the first one first. Let's do the first extraction.
Should I use a small syringe?
Yeah. Doesn't matter. It's not that much liquid, but be careful you don't take anything like yesterday. It was perfect yesterday.
I can see some kind of stuff on the surface of the water also.
Go
so
just underneath of it, possible. You're in guns. I can see you're in the guns. Come up a little bit. It's not such a clear water. Huh? Okay.
I want to show you in a white background. You see the color?
Okay. I think that's enough, huh? Or can you get more out?
Yeah, I think so. Because the sediment is quite well separated, so
Okay.
have a little more. Let me try.
Does it still feel like jelly?
Yeah. Ah, no, the water part is not.
No, the sediment.
Sediment, it looks like it's more like concentrated, more became like a pudding, like.
Oh, okay. She loves pudding.
Yeah.
Everything is compared to pudding.
Using this expression too much. Okay. Then I can see some white kind of dust like stuff inside the water too. Yeah. And some of them are still on the surface of the water, so I'm trying to get rid of this parts. This is going to, it has to be measured again.
Yeah, but we haven't finished. You still gotta go to number 3. You gotta wait for a few minutes. Let the particles in there to settle, and then you choose number 3, and then we do the thing with number 3.
Okay, I think it's maximum.
It's the maximum, okay. Can you wash your syringe and now give it a few minutes, let anything in there. Can you ask him, can he measure this? What's the residual? Can he measure the residual now?
This one.
No, the other one, the gel.
One.
Yeah, can he measure the gel? Is it enough there for him?
これは測定に可能な量ありますか？少なすぎる。
長時間やんないとダメでしょうね。
It takes a longer time, but 2つ測定器ってある。
Do the water first. Can we do the water first? Just give it a few minutes, let it settle. Put it in the 3rd cup, and then let him measure the 3rd cup.
Okay.
Where is the 3rd cup? The empty cup.
3rd cup. Yes.
Okay.
So I wash it again just in case, and then I wash my syringe.
Yeah. This is what we're waiting for. This water. If the water is clear, or it's got a very low amount of radioactive material in it, you can recycle it again 2nd time. Because up to now we didn't have the separation. Now you separate it. If the water shows low level of radioactive material in it, we can always process it 2nd time. Maybe you have to reprocess it 2 or 3 times, but now we see.
Yes.
Okay, go ahead. Do you see any bits in the other one?
There's no bits anymore, but I can. No, I cannot see anything.
Okay,
now.
just try to take from very top. He's brought his baby in. Can we see the magic piece? Moonlander. Open. Okay, nothing is perfect. It's a nice job. It's made a job. Now that piece goes in the center. Oh, that's all you're gonna do. Do you want me to get it coated today? Okay. Too close. You can always rub it out because it's outside the reactor. It doesn't matter. It doesn't see it. It sits here, huh? There's no problem. Oh, Superman. I leave it to you. I'm too old. You are looking for a drinking water.
Yeah.
Yukoko, so...
So I would like to drink this.
No, you don't need to drink it, please.
In future.
If you can do this, even if you can really, what do you call it, get it clean enough that it can go back into the sea, there's a filter system we can take out.
Oh, he's helping me. Okay.
I don't need the history. It's a perfect balance. I like it. This reactor is very, I think it's one of the first reactors. If you get it right, it'll fly on its own without much effort. It's a stainless steel. You can do a lot of things with it. Snow. Where is yours? That's the second core. Did you sort it out on the top to seal it if you wanted? Or you change your mind? Oh God, this is a problem when you go home. Oh. To the thing you wanted. Oh. Okay. So in a way you didn't even go home on holiday, you went there on a working holiday. It's nicely done. If you want it, let me have it. I'm gonna go and see the guys and get it done for you. Can I have your reactors as well, please? Because I've got to go by 2 o'clock or so. I hope. Anything you... No, he wants to heat it. And write the instruction on what you want it to be heated to. Please. And you can do the same if you like. I'm going to take from... Do you see any residue at the bottom, Mikoko?
No, I cannot see my eyes. But, water has
just tip the bottle to the side, then you have more room to go.
Yeah.
Yeah, tip it that way, yeah. We just code it, yeah? You put a marker where you want to. Yeah, I hope so. Then when you get it back, before I forget, you have to... When it's coated, you have to make sure that you get sand, and you sand this, that you make no connection. My biggest problem is with this so tight, you're gonna have connection between the inner and outer. That's another problem we gotta sort out when we get it back to see these figures, how it is. One problem at a time. Shall we take the microphone? No. I think that should be enough. Yeah? Yukoko?
Yeah.
Do you have any more? I think that should be enough. Put the rest back in the first cup. And let him test it. Weigh it and test it, please. Ooh, that's a lot of water. Do you see any residue in there? Wait. Where is the other cup? The second cup you had in your hand. The one you just were taking water from. No. Can you bring it in the picture? Yeah, that one. You still have a lot of water left in there. Can you extract any more or not? Or leave it. Don't take a risk because he can measure himself. It's okay. Yeah. Don't take a risk.
Yeah.
Just the water there is good enough. Let him test the water, please. Cup number 3. We got to see if this is a drinking water condition. Can you? You can't write on these anymore. Just write it on it, drinking water. Let's see how correct we can be. Yukoko?
Yes.
Write on the cup, drinking water. Let's see if you are correct.
Okay.
Seal it and let him measure it. This is going to be another 30 minutes?
Yes.
Okay, put the other water in there as well, please. The second cup into the first cup. Just write on it, drinking water. Let's test our knowledge. We are prepared to be embarrassed. Yeah, empty it into the other one. Finished. Yeah, it's put it in there. And he can measure that now. Let him, if he can run his second machine, Let him run it and give us the radiation level in that material.
Okay.
So we wait 30 minutes?
Yeah.
Yeah. Okay. Thanks, darling. We're going to do some work in the lab. We'll be back in time. Okay?
Okay. Thank you. See you
Thank
later.
you. Don't go anywhere. Just leave it on. We are here. We're not going anywhere. We just, if you need us, somebody is here to call us. Yeah?
Okay. Thank
Okay. Okay.
you very
Bye.
much.
I'll be back in 10, 20 minutes. No. Okay. Let's sort out the reaction. Ciao.
No.
Yes, Yukako Marek here.
Yeah. The college in the laboratory.
They are in the lab. Yes.
Okay. Okay. I think it's because of the sample is very small amount. So I mean I think there is still have some radioactive
In the water.
material. Yeah, in the water.
Mhm.
So that's I could see at this moment. I have to wait until the end of the measurement, but now
Okay.
yes, I could see the process like this. So
Fine.
yeah, okay. Thank you. Are you guys okay? You guys sleeping? Eating?
Sometimes
Yeah.
we sleep.
Thank you so much. I really appreciate.
Are you okay?
Yeah. I'm perfectly fine. Perfect. Yes.
What about the measure of your body radiation?
No, I didn't have any
Any
I mean, but
positive result?
Yeah.
Mhm.
Not only the potassium 40, which is naturally exists. So
Yes.
sorry for that. I was a bit nervous, so that's why.
No, that's
But
fine.
yeah.
I'm glad you are okay.
Thank you. Sure. But I have some results from the people from the Fukushima. This is the blood test. So maybe hopefully we can do some medical test in the future. I have some blood test results from that the girls live in Fukushima, who is 80 years old. So
Hello, Yukako.
yeah.
Hello.
Hello, Jorge.
Could you
Hello,
open
how
a
are you?
little bit the screen because I'm going to dream with this table.
You can forward.
Okay, so you want to also ask about the other people which have some problems with radiation?
Yeah.
Mhm.
I met the mother and daughter. Both had the same symptom in the thyroid, parts. They have a lump, but I got the blood test of the girls with me, so please let me discuss when I go back to the laboratory. Yeah. Are we in the live stream now?
We are.
Oh, okay. Okay. Longer.
You can greet your nation.
Thank you. But, okay. So, are you calculating the change of the weight and the mass of the volume of the sample? Is anyone calculating this?
Recalculating regarding the changes?
Regarding the changes of the weight, yeah? Weight of the sample. I mean, we adding the total. How much we
Yes,
added?
we've added some CO2 and I think that it should be recomputed
Yeah.
to get this into account.
Actually, gentleman here is calculating for us, so I can share the result also, calculated result also. But if you have a same calculation, that will be no problem. But initially we have a 40 gram, and then we added 10 gram. 5 milliliter 3 times, so which is mean 15 grams. So 55 grams of sample in total. Am I understanding correctly? 55 grams of the total sample. 55 grams of total sample, including the original water and CO2.
Yes.
Yeah, okay.
So the CO2 content is
15. We added 15 grams of this.
15, yes.
Yep.
So the result, the radioactivity result can be recalculated because it's relative to the whole mass, whole weight, so it can be compensated later.
Yeah. Okay. Sorry for keep waiting. Sorry. Hello, is Mr. Keshika?
Hello? Hello? Can you turn it up?
Still we can see the film.
Can you come close?
Yes.
Can't see it, it's very blurred. Close, come close. We can't see any digits.
Oh.
Little bit further and don't shake it.
Can you see? Focus
1
now.
minute, 1 minute, don't
It's moving, we can't see any data. Wait. Is this the water?
Yeah.
We can't see any data. Yukoko.
Oh. Okay. Can you see that?
We can't see. There is no digits.
No digit?
No, we can't see the numbers.
It's 543.98 in the total.
In the water.
Yeah.
And what is it?
And the others is the element is cesium 137,
Yeah.
386,
Yeah.
and 134 is 117,
Yeah. And
and the potassium is 73.38.
is 73.38.
0.38.
And the first one was the total?
Total was a 641.
Yeah.
Sorry. Let me get the papers because
Yeah.
it's better. I calculated the reduction, about the weight, and I could see the reduction of 14%. 14% reduction, but total is 40% reduction. Now.
Okay. Okay.
Yeah.
What is the reading of the metal residue?
Reading of the metal.
No, the what do you call it? The residual which is in the machine with the.
Still ongoing. Sorry, there is only one machine available for this smaller container, so we have to wait another few minutes. Yeah.
Okay, can you give me the original figures when we started, please?
Okay.
We can't see it. You got to read it for us, please.
Okay. Okay. The original was 641 in total cesium, total radioactive, and then cesium 137.
Yeah.
That's 476. 476.
Yeah. And 134?
134 is a 165.40.
And
160.
potassium?
Potassium is 230.
Okay, that is very good news. This is very nice. Can you ask the gentleman how did they extract the material? The water was extracted using metals. I want to know if he knows what metals were used to extract.
It's iron.
Iron.
Iron, yeah.
Yes, iron.
But he doesn't know exactly what kind, or it's a liquid of the iron. But
okay, this is good news. But let's look at the residual. When I saw the changes, I thought this will be the result with this. but I thought it might not be. It might get stuck with the gel. We got to look at the gel, see what's the sediment in the gel.
Okay.
Okay.
Okay, thank you.
Yeah.
Back to
This is not a contaminated water directly. They have added iron, liquid iron, trying to absorb the material. So now the material is floating in a way we cannot do it. It's a liquid metal. Huh? But it's a very good test. He told us from the beginning that this is coming from university. They've done a test with, they tried to add heavy metals to see if the potassium, or what you call it, radioactive material, attach themselves to it. And they use the liquid metals, which is a process we understand, but in a way is something they've tried. Because the other one we had yesterday, we extracted ourselves from the water. So we've got to see if what's the residual in the water from the soil.
They can't get really water from Fukushima?
No, we got to stop the test because she's got enough to go to Fukushima. This is still a good indication that as I said, it's like a blood. And I expected this because in blood you have iron. Then it teaches us how it is, and this is very clear indication how you expect cancer in the blood with leukemia with the target material. The target material was yesterday because it was solid. I told you it was like what do you call it, weed and things like that. It's attached. You can get to that. This shows the same with what we thought it will be like leukemia. It's very much. Yukoko. Hello.
Hello.
Hello. Yeah, the result you have here with your water is more or less, it's worse than I thought, but I gathered that you will not have a result like yesterday. And I explained this morning that this test you're doing is like a leukemia, and the test we did yesterday was like a cancer lump. Because this has a metal, the guy told us this morning that they use a metal to try to extract, and that metal is holding into the radioactive material. This is expected because there's not much we can do because the matter is attached to a metal. Yeah? So we understand. This I understand. If you had a pure water like directly from Fukushima without a liquid metal in it, you would have more or less the same result as yesterday. Okay, so this is what I was expecting. And I explained it this morning. This will be like a leukemia. Because it has iron, and we see this. But the good thing is, even with the iron, you see such a reduction. So we can repeat the process 4 or 5 times. You come to more or less near clean water. You understand?
But it takes
a few times.
Just repeating the same
yes,
process,
this is the reason why I asked you to increase by mass 3 times. Because first of all, I wanted to see the ratio, but the minute we started, he told us it's being cleaned with metals. And I gathered, so this will be the position, but now it's a good confirmation because we have to handle such a situation in Fukushima in the reactors. Because the metals has been it's come to like a powder, radioactive matter is coming like a powder or whatever. But we can see what the percentage is. But yesterday was a natural with resin, what do you call it, remains of the wheat or whatever, natural products. So the system, it was like a lump cancer, so it had places to attach itself to and work with. That's why you saw the result you saw. This understood. Ask him if he can find out from the researchers what metal was used, or what liquid
yes,
metal was
it's from
used?
the laboratory of the university, so it's kind of like very
Secret.
closed, experiment.
Okay,
yes. And
no.
then
Even this is very good because on cesium you're down by nearly 90. Cesium 134 you're down by. Who's got a calculator? A calculator.
Oh, I calculated
No, that's
my handwriting is awful.
your handwriting. What is 386 divided by 476? What percentage you get? 1? It's 18%. Okay, if you do 117 by 165, $71. 117 divided by 165. 165.
165.
How much? 70. 71%.
How could it be 7%?
What is 73 divided by 230? I know what he's done. He's 81. He's gone the other way around. Okay. 19, 29, and how much was it?
The last?
Yeah.
32.
78%. Okay. You have a 19% reduction in 37. You have 29% reduction in 134. And you have 78% in potassium 40. Yeah?
Yeah.
What is 543 divided by 641?
So
641.
hello.
Okay, total reduction on the radioactive material gamma rays, because there are other components in there as well, is 15%. Your cobalt, what do you call it? Your 137 is 19%. 134 is 17%, and potassium is 78%. With such a little amount of material you put in, this is still fairly good result. Knowing that you carry a metal container with you, metal carrier. I want to see the results of the gel.
Okay.
This is a very good news for what you have. Explain to him why he doesn't see the same result, because of the ion float.
Yeah. Okay.
Yeah.
Okay. Thank you.
This is why I explained that this is like a leukemia with iron. That's what it's called. This is one of the problems we have with leukemia cancer. This is what there is a huge problem. Or in a way it's easy because it's a small amount, but targeting cannot be done. You found your glasses?
No, I went home.
So this is what even this morning I explained those with the weed. Yesterday you have solid matter. It's easier to target or absorb because most of the radiation in that liquid that they gave us yesterday was already attached to the vegetable. Yeah, so that's why I said this before the test was done. I said this is or you now you gotta go and buy, what do you call it, seaweed, so you get the process much easier. Yeah, it's a different lab. That was this is where we were on Saturday. So in fact, you can take that part, go to the TEPCO and give it to them and tell them to test with the cesium, with the, what do you call it, with cesium and what do you call it, tritium, because I think they'll get the same result. Well, enough to do a small shot. We used a lot for this, but in a way it's needed. She can show the result of the test to TEPCO. But we had to understand. But originally, when the reading went up, there was that's why I said there is a plutonium elements in here. And then when we check with Marak, this is a confirmation of the existence of plutonium, because your reading should not go high than before unless it's coming from somewhere to that level. So there is plutonium which with presence of iron leads to production of cesium. So the cesium went up more than actually it was originally, which cannot be. A second test, which cannot be. So it shows that they are only measuring the gamma rays, not the alpha rays. If you use alpha rays, you see it and they move it. That's what Marek said, I think. Cannot be shown. No, we're in a situation. This is a very good result. This is a very good result because we know they've used the iron. Yeah, this is a enforced condition. What you can do, if you have iron, you put magnets around your core. You extract the ions first, then you do your decontamination. You understand? Now then you still have a contaminated ion. Your ion is not gonna, so but then you handle it in a different way. That's not a problem, but there is a clear indication there is a plutonium in this material, because we had more 137 than we started with. So it has to come from somewhere. Or we had more 137 than we had on the previous process. So there is a reduction from somewhere. Definitely. This material is most of the material in the fields in Fukushima are military based. Reactor 1 has been used totally for military application. Every indication shows. So with this one, you've got to, what do you call it, do the process. But if you see again increase in 137 in the process, means means there is more plutonium coming out, what do you call it, decaying down to 137.
changing. Yeah, but you feel anxious, right? What's the word for
Hello, Yukoko. Hello. Any results?
Yeah, it's very interesting results.
Yes, she said.
It's very interesting because it show actually, I mean, smaller amount of the
We can't
contamination.
read. Can you read it for us, please?
Okay. This is with the CO2 sediment.
Okay, let me write it down. Let me write it down, please, darling. 1 second. CO2 sediment, yeah?
442 in total cesium.
Yeah.
And cesium 137
Yeah.
is 319.
Yeah.
And cesium 134
Yeah.
is 123.
Okay, and the calcium, potassium.
Potassium is a minus. Now it's a negative, which is mean they cannot detect.
Okay. Okay.
This is, I mean, this is amazing. This is actually this is a smaller. I calculated by the mass because it's got the 27 gram now.
Mm-hmm.
Yeah, and I mean the ratio of the reduction is even smaller than the pure water part.
How much
I mean
is
that
it?
the clear water part. Clear water part. I could see the. I recalculated. I'm going to send you the.
Yeah. Okay.
But
Just tell me by mass. Yeah.
Yeah, I could see the 40% reduction.
With
14.
the water.
Yeah, for the clear water.
And
From the last one when we added. Yeah, but the other one is could you calculate it? 298.94 divided by what's the ratio? 467.55.
can you do that, please?
Okay, I do. Okay, I am bringing my calculator.
200 and she's running away.
That is amazing. That the gentleman was really impressed by this result, and then okay.
This confirms what I said. This seaweed process.
37% reduction.
How much?
37-point reduction. 37%. So 37% reduction.
37.
From the 50. Yeah. So previously, the top clear water has 14% reduction.
Yeah.
But actually, with the sediment is more decontaminated.
Yes,
to
this is what was expected in a way, because we saw the same performance yesterday with vegetation.
Yes.
So what happened? The nuclear material attached themselves to the CO2 through the residual, so it has the what do you call it? The magnetic field, gravitational field, to attach and process it in a way. I don't think we destroy the what do you call it? The cesiums or whatever. We just convert them to a Ganser state. That's why you don't see them. You understand? So the process is very clear. If you would have had a magnet and you could have put on.
Goes further.
Pardon?
I mean, do you think the process is going further? The gentleman
you can repeat it. Yes, you can repeat the process.
Take a minute. Yeah.
Let the
Okay,
let.
so,
I don't think the only way you're gonna repeat to increase the process, Yukoko, I think you can ask him to add sea salt to both material, residual and the water, and test it. Add, let's say, 10 ml of salt water, sea salt, to each
10
one,
milli of
and
okay.
carry on
How much
testing.
the
Pardon?
How much is the concentration of the salt water?
You take what do you call it? It's not a concentration. Concentration you do it like 40%, 30% concentration sea salt, and you add to it. But
add it to the both container, both sample.
Containers,
I
yeah,
mean,
because then you see, because you already have a CO2 within the system. When you add the salt to it, it uses the iron as the electrodes we put in the containers here. You understand?
Yeah, so
in a way you allow the process of the growth of the CO2 in the container.
Okay. So
if our assumption, yes.
Reduction.
Yeah, the reduction comes because of the production of CO2 using the metals which they injected into the water. You understand?
Okay.
So if there are two different metals component in that liquid, or he told us he could see zinc and cobalt. We presume zinc and cobalt will behave as other electrode. So if he adds sea salt, 10 milligram to each side, and let him run and see if he gets a reduction.
Okay.
Because in a way he cultures the CO2. He has to leave the cap open. He can't close the cap. When he adds the salt, the only way he's going to get CO2 from is from the environment.
Okay.
So he has to leave it for a day, and then run the test, let's say, on Wednesday.
Okay.
The reduction will come not because of the material. The reduction will come from the growth of the CO2 absorption from the environment. But this is a very nice test for us to have a look at if it happens and to what extent happen. One of the reasons you see a small reduction in the process with the other test, because of the potassium in the water, that potassium behaves like an electrode. So you still generate CO2 in a very slow process. I've done this before, so I know the process. Yeah? It's if it's the way I say to you, nanomaterials grow on the material, even though you what do you call it? You sandpaper it. This, if it works, it'll be in a liquid state doing the same thing. So if you tell him to put 10 milliliter of the salt, 30%, what do you call it? Saturation. And test the material the day after. But the caps has to be open, that CO2 is absorbed from the environment. All you do, instead of the way you are injecting CO2 into the container, and today by 5 ml at a time, the process will carry on itself if you are correct. And in this situation, I think we should be correct.
Okay.
Yeah. So tell him he can test the material every 2 days, 1 or 2 days, and see if the reduction carries on for a week or two. Whenever he's got time, just put it in. So it becomes a self-sustained process.
Okay.
If you are correct. I think we could be quite correct about that. But then it comes to a saturation point again of how much conversion. From the result you gave me, I'm 100%, not 99% sure of what I assumed. That there is a plutonium factor in this game, because we cannot have more 137 when your total numbers have reduced. Yeah.
Okay. Yeah.
So this in a way confirms again the same situation, that there is a plutonium factor in this game, and this is where a lot of problem comes, and this is why they are putting so much secrecy acts into the laws of the Japan. They don't want the workers to talk. But now you have you have 100% clear indication. You understand? That's why I wanted him to explain to me his chart, the way he sees it. You understand?
Yeah.
So
I understand.
he's carrying cesium, he's carrying cobalt with the high peaks, and on the left hand side, these are, as we were discussing with Marek here, these are all gamma radiation detectors. Ask him, does he have an alpha radiation detector with him?
Alpha, okay.
Or beta? That's the sediments. Keep these two till she sends us the what they call PDF file. That's here. So I'll write it here that we have it in. That's the sediment. Sediment, and that's the water. 54398. 137 is 386. 134 is 117, and cobalt 40 is potassium 40 is 73. 38. This is gone. It's disappeared. So she sees it as a. They see here at 37 reduction. They see here biomass at 14% reduction, which is very understandable. Because the CO2 is but in another way, this can explain that iron rejects magnetic gravitational field because of this environment, and that CO2 cannot come close to the radioactive material to absorb. It's like, you know, the channeling.
So they added colloidal iron.
Yeah. They added liquid iron. We knew it when he started. He told us that this material has a, what do you call it, ion separation. So immediately, that's why I told you from the beginning, this is, you know, you got the leukemia, and we have that because in the blood you have iron only, and that's one of the problems of leukemia cancers, sort of. Where here, as I told you, it's like a mass cancer. So it's in line with the research in medical. See the parallel with it. But now we can allow the CO2 to be if because of the metal injection. But this is a fantastic news, because the metal injection allows us to carry the process of the what you do in the containers as well. But in the reactors, what has happened, the sea salt from the sea water, which is broken in, has added to the conversion itself. Understand? That's why when you add the salt into it, we see if we can process the same cell.
Some copper guns.
Yeah, I want her to deliver it to TEPCO tomorrow.
Do you have enough for another test?
No, very, very nice. To do what with the water? It's 8 o'clock, 10 o'clock there at night, and she's leaving tonight. But it's a good point. We can, if she delays her flight by a week, she comes. We can, what do you call it? We can test. But I think we gotta go to TEPCO with what we have. She's coming the happy way. Hello, happy Coco.
Hi. So I think he can continue this experiment. But
is he happy to do it?
Yeah. He's very interested in to get this results. Yeah, what we get today. And then he also then there is some hypothesis from him about that what kind of ion that the ion inside of the sample. Which might have because it's as I told you that it is melted iron.
Yes, so I understand what it is. It's a liquid iron.
It might be used in the very strong alkaline. To make it, and probably it's adjusted by the pH controller, and that usually he knows that what we work in yesterday, that the water inside, which has the wheat, is usually very acidic. So it's kind of an opposite condition. I mean opposite component in the sample. This is what his hypothesis. That's why we got a different kind of results.
It's another point of view. This could be right.
Okay,
Yukako, what I would like you to, is very late for you there. Please get yourself to TEPCO. I try to speak to people in TEPCO tomorrow morning if I can get hold of them. That if you call me, let's say by 10-11 o'clock your time tomorrow, just call me on my Italian number and put your phone down. I'll call you back.
Okay,
you don't need just to call me. When I hear the ring, I'll call you back on the same number. Then I try, if I can raise TEPCO, I raise TEPCO. Otherwise, I give you an address to go to the committee of the TEPCO, and you hand the samples there, and you give them a copy of the data. You may run a copy, run 3 copies of all the documents you carry, leave 1 in Tokyo, bring 1 with you, and leave 1 with TEPCO. And send me. We have all the what we need. We need all the documents and all the results today. If you can send it to Marek. We are releasing a paper on this, and now we have the data. We speak to the relevant people respect to this job, but maybe we have to ask you to stay in Tokyo. Yes, please. Maybe we have to ask you to stay in Tokyo a bit longer, that you can negotiate with TEPCO. You can negotiate with TEPCO directly online of the material. I'll produce the CO2 while you're there, and we send it to you. That they can run more. And I'll speak to the IAEA, International Atomic Energy Authorities, tomorrow in Geneva. That we inform them that we have found a solution, data done in Japan, but we need PDF of all the papers you have. Put them in order, scan them, and send it to us. And then I'll send a copy to Iranian Nuclear Center as well for their inspection and valuation. They can tell us what we see, and we send 1 to, what do you call it? We got to send 1 to both American and Russian embassy. Then we'll see. We put the things out automatically across all the across the nations. Then I think you've done a fantastic job. It is amazing what you achieved in 3 days. It takes a year, 2 years for TEPCO to achieve. Women.
Your support. Thank you so much. Thank you very much. All knowledge seekers there.
Thank you very much. We've been with you more or less for all the time we could.
Have a very short but intensive.
Thank you very much. Please look after yourself. Give my regard to your children, and stay put. Call me about 10-11 o'clock your time tomorrow morning, and by then I would have spoken to these guys in TEPCO that you're going in.
Thank you very much indeed.
Thank you very much. Have a nice day, whatever is left of it. Bye-bye. Bye-bye.
Bye.